Okay, this is our video on greases. There's always a debate, what's better, grease or oil? Well, they're both really good. It depends on the application. Anytime you use a lubricant, you want to follow the equipment manufacturer's recommendations. That's pretty much a given. There's a lot of different types of greases used for different applications. The bearings that you use, some may be a sealed bearing, which too much grease will blow the seals. Other bearings are designed to be grease and flush them out, keep the dirt particles outside the bearing. Grease versus oil. From the standpoint of lubrication alone, to reduce frictional power losses, minimize wear, and prevent abrasion, oils are probably better. Oils also remove heat from the bearings, and they can flush out particulate if you have out of the bearing. Greases tend to separate under high temperature and speed conditions. They have greater internal friction. So from the standpoint of lubrication, oils are better, but in extreme conditions, greases are more practical when dirty environments. Grease seals keep dirt out of the bearings. As we mentioned, some bearings are sealed, some you grease and you can keep the dirt and environmental contaminants outside the bearing. Bearings have inaccessible machinery. Grease lubrication generally requires less attention. These would be like exhaust fans, a lot of conveyor bearings, that type of stuff are grease lubricated. Their freedom from dripping or splattering, grease is used. Extreme operating conditions, high temperature, pressure, low speed, shock loads. This is where greases really excel. Different compounds can be added to change the characteristics of the grease and prevent metal-to-metal contact. When you have large running clearances, agriculture, construction equipment, mining, greases are definitely superior. Where seats and retainers are badly worn or lacking and frequent attention cannot be given, you can use grease on that. I've seen gearboxes that are packed with grease after the oil seals failed. They worked just fine. They were low-speed gearboxes and not ran very often. So greases are definitely better for certain applications than oils are. What is a grease? It's from an early Latin word meaning fat. The ASTM definition, American Society of Testing Materials. It is a combination of a petroleum product and a soap, or a mixture of soaps suitable for certain types of lubrication. Basically, it's a soap-oil mix. You have your base oil, and the soap thickens it so that it'll stay in the bearing. Your base oil is 75 to 98%, thickeners 2 to 20%, and additives 0 to 10%. So these determine the characteristics of the grease and its application. Greases are made by saponifying its reaction of a fatty acid with a base metal with a fatty substance, and adding oil to the soap. This is soap thickened oil. This basically is using like sodium hydroxide in an oil, make a sodium based grease, or lithium hydroxide, make a lithium based grease. So it's basically making a soap, and it holds the oil in suspension. Solid materials such as graphite, molybdenum disulfide, talc, PTFE, polytetrafluoroethylene, type of Teflon. These protect against grease film rupture. You'll see like a lot of moly greases, graphite. These are for extreme pressures. These are greases where the loading is very high on the bearings, and they do provide against metal-to-metal contact. Some things you'll see when you're buying a grease: dropping point, temperature where the oil and the thickener separate. You'll see this on grease that's been stored in warm environments. When you put it in the gun, the oil will run out of the bottom of it. So this depends on the temperature, how much dropping point protection you need. NLGI consistency numbers. It's the grade of the grease. There's 9 of them. You'll probably only see just a few grades. The relative hardness of a grease defined by ASTM D217. It's a code and penetration of a lubricating grease. Say there's 9 grades. 1 to 3 are the most common. You'll probably see 1 and 2 is mostly what you'll deal with. Number 2 grade is really, really common. There's triple aught to zero. This is low temperature grease. There's also food grade greases, greases that you use for like traveling screens that are more water resistant, trailer bearings and stuff. The thing you'll see is the 4-ball test. They use 4 steel balls. It is an extreme pressure rating. The pressure is recorded that causes scarring and welding of the balls. This will give you an idea how well the grease can handle extreme pressures. So if you have high pressure environments where there's a high loading on the bearing, this becomes really important. If it's motor bearings, you need a grease that's a light grease, probably a 1 or so, that will keep the ball bearings from hitting the race and protect them. The types of greases, there's lithium. It's a 12-hydrostearic acid with lithium hydroxide monohydrate. It's widely used grease, probably 7% of your greases are lithium. Has excellent water resistance, thermal stability, and storage. It's probably the best multi-purpose grease developed. Pretty much all your greases are going to be lithium and probably a 1 or 2 consistency number. The polyurea is a newer grease. Uses a thickener powder made with isocyanates and amines. This product can be added to base oil. So they take a powder and add it to the base oil and it thickens it. It is not a soap. It does not mix with other greases. This is really getting to a big problem. If you add this grease to like a lithium product, the grease will fail. They have inherent oxidation stability, thermal stability, low oil bleed characteristics, long lifespan. This is really a pretty good grease. You're starting to see a lot more of this used. Calcium sulfonate. It's made by converting a fluid detergent that contains amorphous calcium carbonate to a grease containing calcite particles. Calcite particles form wafer or scale-like structures and they create shear planes between the metal surfaces. So if the oil fails, it's overloaded, the calcium particles will take the wear instead of the metal. That's a good choice for high temperature operation, high loads, have rust inhibitor detergents in oil. So basically there's all types of greases made with all kinds of different products, and that's why it's important to follow the equipment manufacturer's recommendations. Every grease has its certain application. And if you start mixing greases, you can have problems. You can have failure of the bearings because the oil separates out and runs out of the bearing. Also depends on the type of bearing. If it's a motor bearing or a sealed bearing, follow the manufacturer's recommendations on greasing. Do not over-grease those bearings. You'll destroy the seals in them. Other bearings in dirty environments, you can grease them every day and you can grease them quite a lot to flush dirt out of the bearing. Once again, it follows the equipment manufacturer's recommendations. If you have bearings in dirty environments, like on wood chippers and stuff, you definitely want the bearings you can grease every day. Keep the dirt out, water out of them. So basically there is no answer what is best, oil or grease. Depends on the application. But greases are really useful in a lot of industry. And you just have to use the right grease and lubricate the correct amount.